What's up, Math 8? Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at lesson 4.5, dilations. We're going to be able to identify what are dilations, be able to use them, and then also use scale factor to dilate a figure. It would be helpful if you got the printout notes from class today because we are going to be graphing some things just like we have been doing this entire unit. So make sure you have that, or make sure you have graph paper available. First thing we want to know is, what is a dilation? A dilation is a figure that is made to be bigger or smaller as respect to a point. You will be able to get a center of dilation, and that's just the point to use to create the dilation, so about the origin or about point C. The last thing is a scale factor, and that's how much a figure is increased or decreased. A lot of the times we see this being used with the letter K. You can also find the scale factor by taking the new image over the original, okay? A lot of the times I just tell my students to just say no, and that'll help us find the scale factor of that image. What we're going to do now is just tell whether the blue figure is a dilation of the red figure. Remember, dilation just meaning the shape is getting bigger or smaller. So for letter A, that one should be yes. Letter A shows the red figure getting larger than the blue one. Letter B is a no, though. This is a translation. Number 1 is no, that one is considered a reflection, but number 2 is considered yes, it is a dilation. The red figure actually got smaller from the blue figure. What we're going to do now, sorry, bells are ringing. What we're going to do now is talk about how we can show dilations using an algebraic sentence, which just means showing that with letters. Algebraic dilations are going to be shown kind of like we saw when we did our translation rule, where we have x comma y, an arrow, and then what's happening to x and y. Notice that the letter K is being used because letter K represents our scale factor. How much is it getting bigger or smaller? Okay. When we use that scale factor, we're just going to multiply that by the letter x and multiply it by the letter y because we're going to be plotting these points on the coordinate plane. When K is greater than 1, the dilation is going to be considered an enlargement, which just means it's going to get bigger. But when K is greater than 0 but less than 1, the dilation is a reduction or smaller. Like we're thinking like 1/2, 1/4, 1/3, 2/3. These are all less than 1 but still bigger than 0. So what we're going to do first is identify and write the rule for the following dilation. You do have to have some knowledge of the pre-image and the image. This one down here is considered the pre-image because the letter A is just the letter A, where here is the image because it has the prime symbol next to it. So let's start by just focusing on how letter A started and how letter A ended up. Right now, letter A is at 0, 2, and A prime is at 0, 6. You can even look at how B changed. B was at first at 2, 2, and now B prime is at 6, 6. How this dilation happened is we would consider this an enlargement because the previous image or the pre-image was smaller and then it grew to be a larger image. We also want to write the rule, so we're going to write x comma y and then what we think was multiplied by to get from 2 to 6. 2 was being multiplied by 3, so our scale factor is 3, so that means we should see 3x comma 3y, where scale factor is equal to 3. Okay, let's try another one. Now we're going to draw the image and then do a dilation of 3 and then identify the type of dilation. So the first thing we want to do is go ahead and draw the pre-image, which is at A, B, and C. 1, 3 is A, over 1 up 3. B is at 2, 3, and C is at 2, 1. Okay. What I'm going to do now is I'm going to show the dilation with a scale factor of 3. That just means I'm going to multiply each of these numbers by 3. Okay, so that would do for A prime, 1 times 3 is 3, 3 times 3 is 9. So my new point would be 3, 9. B prime, 2 times 3 is 6, 3 times 3 is 9. So B prime is at 6, 9. And C prime, 2 times 3 is 6, 1 times 3 is 3. Now let's go ahead and plot these new points. A prime is at 3, 9. So I go over 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7, 8, 9. B prime is at 6, 9. So 4, 5, 6. And C prime is at 6, 3. 1, 2, 3, 4, 5, 6, up 1, 2, 3. This shape should look similar to the one we had before. It has now just been enlarged as a dilation. So this is an enlargement. Okay, so that was what our answer should look like for this example. Now we're going to look at the image and do a different type of dilation. Notice that this scale factor is 0.5. So let's go ahead and first draw my original points. -4, -6. That's 1, 2, 3, 4. Down 1, 2, 3, 4, 5, 6. Here's W. -4, +8. 1, 2, 3, 4, 5, 6, 7, 8. It's going to end up here. And mine went kind of off the screen. Then I have 4, 8, which would end up over here. 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6, 7, 8. And then Z is 4, -6. 1, 2, 3, 4. Down 1, 2, 3, 4, 5, 6. Okay. Once we take these, now we're just going to line up and make connections. Sorry about that if your graph paper wasn't large enough. Our main goal, though, is just to remember we want to see how this is affecting our original points. Okay, since my scale factor is 0.5, that means my rule would be 0.5x, 0.5y, which just means I'm going to multiply each of these numbers by 0.5. So W prime, if I do 4 times -0.5, or sorry, -4 times 0.5, I'm going to get 2. So -2, -3. What you're going to notice is that each of these is going to be cut in half. X prime, -2, 4. Y prime, 2, 4. Z prime, 2, -3. Let's go ahead and plot these new points with a new color. W prime, -2, 3, to the left 2, down 1, 2, 3. X prime, -2, +1, 2, 3, 4. Y prime is 2, 4. And Z prime, 2, -1, 2, 3. Again, this should be a similar shape than what you had before, not identical size, but same type of shape. They're both rectangles, and this is clearly a reduction. Okay. The summary for whenever we see dilations, we can say we multiply the coordinates by the scale factor to show the new points for the dilation. Okay,